smart lock idea originated from a common mishap that happens to almost everyone, forgetting their keys. It's an extremely common occurrence for people to forget or lose their keys upon return to their home and lock themselves out. Fortunately, with today's technology, one does not necessarily need their keys to lock or unlock their door. What Smart Lock actually is the use of an app that allows the user to operate the door's deadbolt locking mechanism through the use of their smartphone. Our team first became interested in the Smart Lock concept when a mutual friend of ours and roommate of mine constantly lost his keys over and over again, but always had his phone on him. We quickly thought that presenting the option to lock or unlock the household door by phone would not only greatly benefit our friend, but also help many others.
We considered 3 different mechanisms to lock and unlock the door. The first method of operating the lock was to use gears. Using this method, a pair of gears and a motor would act to unlock the door by having one gear fixed to the motor shaft and the other gear on top of the deadbolt knob that locks the door. Some benefits of this design is that it would be very simple to produce, as the design is completely external. However, one major downside with this design is that the motor would need to be able to rotate in both directions to both unlock and lock the door. The second method that was considered was the use of a crank slider. In this mechanism, a motor would rotate a crank arm which would extend and retract a slider. This slider would then be attached to the deadbolt itself, thus unlocking and locking the door as the slider moved in and out. A benefit of this design is that the motor would only need to be able to rotate in one direction. The major drawback of this design is that it would require making modifications inside the door, which would likely be impractical. The final method that was considered was a cam. This mechanism would again use a motor, this time attached to a cam that would rotate and push a follower arm attached to the deadbolt, which would lock and unlock the door. The follower would then have springs attached such that the deadbolt retracts when the cam rotates back to the original position. Similar to the crank slider mechanism, the cam design would only need a motor to rotate in one direction, but again, it requires internal modifications to the deadbolt itself. Once we had developed an idea for the 3 different mechanisms, we then decided to create a decision matrix in order to better compare the designs. Based on our criteria, we decided to select the gear mechanism as the design that we would prototype and eventually use in a final product.
The gear mechanism design was selected over other alternative conceptual designs for many different reasons. The main and most influential reasons that our team went with that design is the fact that it involved the easiest manufacturability. Installation of the lock would be generally simple with no internal changes to the door or the locking mechanism itself, and the cost of the manufacturing would be relatively cheap.
In order to fabricate our design, we had to model the components that would need to be manufactured in SOLIDWORKS. The models we created include a motor gear to sit on the motor, a lock gear that would attach to the motor gear and act to turn the deadbolt, and a housing that would hold everything together. With these parts developed, they were sent to be 3D printed and the final prototype was created. In this prototype, the green styrofoam symbolizes what would be a door, while the gray housing sits on top of the deadbolt faceplate. As you can see in this prototype, the design is open so that you can see the inside and see the gears moving to lock and unlock the door. This is solely for demonstration purposes, and the housing would be closed off in a final product. Here you can see our prototype operating as intended, acting to both lock and unlock the door. Please keep in mind that this prototype only features the mechanical aspects of the design and does not yet feature the smartphone app that would appear in the final product.
Our product would cost around $55 to buy and would be a much cheaper option relative to the other designs on the market. The $55 covers the cost of the motor, the housing, the gears, the circuit board, while still allowing us to have around a $10 profit per unit. In comparison to the cheapest August home lock, which costs around $100 and still requires the buyer to remove the entire door lock for installation. To find a similar lock that can be retrofitted over the deadbolt, the prospective buyer would still be forced to pay upwards of $275. Our price is therefore the smartest choice for the buyer. Our next step in the production and marketing of the prototype would begin with implementation of the Bluetooth system in order to lock and unlock the door by using one's cellular device. In order to do this, the Bluetooth chip must be installed and the app must be programmed to connect with the chip. Upon completion of this step, the app will send a signal to the Bluetooth chip, activating the motor's rotation, locking and unlocking the deadbolt. With the mechanical design already being completed, this step should not take too much additional work. Next, the exterior design of the lock can be modified to have a more appealing appearance to catch the eye of potential customers. Finally, the only additional feature step required is the advertisement and sale of our product. The biggest challenges going forward upon completion of our product is really going to be getting the smart lock name out there in order to become relevant in the door lock market, and in order to eventually surpass our competition. The team did run into some challenges along the way, the biggest of which were with regard to manufacturing. There were consistent issues with the 3D printing throughout the whole design process. I guess the biggest lesson to take away from these challenges is to always prepare for failure in machine production and give yourself enough time to repeat the manufacturing process in the event of that failure.